Hello and welcome to the fifth part of the series in which I'll be showing you how to create multiple carriages, link them together and have them move in unison. Now I'm going to be continuing this episode based on where we left off with the advanced rig, and I'm going to be ignoring the simpler rigs that we've created earlier in the series just because you should be able to figure out how to connect those by yourself. But if you do need help with those, let me know and I can look at making a video for those. Anyway, to begin with, I'm going to start with what to expect at the end of this video just because it's going to be quite a long one and I want to make sure that you're investing your time wisely. So as I scrub through here, we've got a nice chain of carriages of different lengths, all moving nicely together, positioned where they should be without any sliding or errors whatsoever. We've even got these little links in between which are purely visual. However, they do look like they serve a mechanical purpose just because of how well constrained they are. It kind of looks like the carriages are actually being held with this link, but it doesn't actually serve a mechanical purpose. It's just, again, purely visual. The only reason it looks convincing is that the wheel cages are in the correct positions, so it looks as if it's binding them together. Anyway, I'll explain how this works and one of the main benefits of this setup which I've got here. So what I've done is I've essentially keyframed the data for the front wheel cage offset, and then I've taken those keyframes and stored them into a pool of data essentially, and then used that data to now control the offsets of these carriages here, and I'll explain how that works later on and how I did that, but first I'll just demonstrate what to expect, or the benefits of it. So as you can see, we've got these locators which you should be familiar with if you've been watching the previous episodes in this series, and they're all nicely locked in place. You've got the green ones and the yellow ones nicely intersecting, with the green ones representing where the wheel cage currently is and the yellow ones saying where the wheel cage should be. Now as you can see, they're all nicely in place except none of them have keyframes. They're all being driven by one driver parameter on this parent null, which contains all the carriages and the train and the links in between. So if I was to go into this driver and create a keyframe, then just get some handles. If I move this keyframe, you'll see that all of those locators are still nicely locked in place regardless of the driver's animation keyframes, and the same if I adjust the easing, they still stay nicely locked in place. So what I have here is essentially a dynamic setup. So all I needed to do was keyframe the offsets of the front wheel cage once along this track, then I could recycle and repurpose it across each of the carriages, and it allows me the freedom to amend the train animation as much as I want without having to redo those keyframes. So that's quite a big bonus to this rig. So I'll explain what's going on and how I did that. So I'm going to go into the train, and as you can see as well, this setup is now a lot cleaner. Like the final output looks a lot cleaner to what we had before. We begin with the driver, which drives this train. It's the same as a carriage, I've just named it train because it's the first one in the stack. We get the driver, which then feeds into the back wheel cage, which you should be familiar with already. Now that goes into the range mapper, which calculates the new front position. Now this range mapper is where the secret ingredient is with this spline field. I'll go over that in a moment, but this spline field is basically calculating the offset for the front position based on the back position. So it's the same as that whole Expresso setup that we created earlier on, just all contained within a range mapper. Now we move on to the next carriage and we take the front position of the train and we feed it into a range mapper to calculate the back position of the carriage. Then we feed that into a range mapper to calculate the front position of the carriage. And then we do the same thing for each of the other carriages, moving along to get each of the wheel cage offsets. So each of the wheel cages are relative to the previous one, and that's how I've got all of these to work as a nice chain, so everything's relative to this back one here, which is what I've called train. Now, how I got that data, like what is this data, what is in this spline field? So what I've got is, on the x-axis, I've plotted the back wheel cage positions. So at 0, which is the start of the railway track, I've plotted the back wheel cage position, and then kept plotting the positions all the way up to the end of the track, which is 1. So everything between 0 and 1 is the back wheel cage position plotted all the way along this track. Now in the y-axis, I've got where the front wheel cage should be relative to the back one. So what I've done is I've gone through, and as I've keyframed all the back positions, I've also keyframed all the front ones with the manual offsets included, and recorded it in this graph. So then this graph is basically saying where the front wheel cage should be relative to the back position. Now that explains how I've got the wheel cage separation here. That's how I've managed to get this. Now for the first carriage, I also have a range mapper here, which calculates the distance between this wheel cage and this one, which is basically doing the same process, except I've done an 8cm offset rather than 16.3. Now I also recycled that data to create these smaller carriages, which also happen to be 8cm in distance between each other. So as you can see, the data can be reused as much as you want for whatever purpose you need. In order to get this data though, what we need is the advanced rig which we had before, and I've named it the data gatherer, because what it's going to do is go through the track, gather data, and plot it into spline field here, and then we can save that preset, which we can then load into the range mappers. So this data gatherer is literally the same as where we left off, except it's got a user data group which allows us to take the keyframed data of the front and back wheel cages with the front wheel cage offsets and record it in this graph, and then we can use that for the range mappers. Now how we get the keyframes into this graph is with the use of a Python tag. Now I know a lot of you are probably terrified looking at this, but bear with me. Like I'll run through it step by step to explain what's actually going on, so hopefully you'll walk away with the knowledge of how to do these things, or worst case you can just look at the script, copy and paste, which I don't recommend, but if needs be, I'm not going to blame you, because it is quite scary and you don't come to cinema to use Python. So without further ado, let's make a start. Okay, so I'm going to begin by removing these cubes because we don't need these anymore. So yeah, let's begin with setting up the final output. So create the parent null for training carriages and create the driver for it. So I'm going to give it a user data tag and create a driver, percentages, yeah. I'm going to turn off the limit minimum and maximum. I won't exceed those anyway, but this will come in handy if you're thinking of looping the animation, and I'll cover how to go about that later on as well, but for now we'll just ignore that. So we've got the driver, that's nicely set up. I'm going to create a copy of the train carriage, which I will call train. We're going to clean this up a bit because we don't need a lot of this. We don't need this tag, we don't need the user data on it anymore. So we can just turn this back into being a normal ordinary null. So if we go in here, remove, there we go. Get rid of this dummy front and get rid of the espresso tag on the back. And the front one, oh look how messy it used to be. Yeah, let's just get rid of all that. And there is one more important thing to consider here. You need to set the priority to -1. Now this is important when we start adding all the other carriages and stuff, so make sure you don't skip this step. Drop the train in the training carriages null. And there we go, that's the setup prepared for the output, so we can turn that off now. Now we move on to the other train carriage, which we will call data gatherer. This is what we're going to be using to gather the data. So everything is the same as before, which is great. What we need to do is create a group, which gather data. Oh, I should say gather data. That's what it's going to be doing. I'm going to say gather data. I'm going to need frames, which will say how many frames we're going to be gathering. Now, we don't need this to be animatable, but we do need this to be an integer, because otherwise Python tag will kick up a fuss if we use a float value. So make sure this is an integer, and again turn off animatable. And we don't need to limit the max, but we can keep the minimum at 0, it doesn't matter. Next we're going to say data gathered, and I'll say wheelcage separation 16.3 centimeters, because that's what we're going to gather first. If you want, you could recycle this setup, but for the sake of this, for the sake of demonstration, I'm just going to do new fields for each set of data we're going to be recording. We don't need it to be animatable, but we do need it to be a link. Oh, sorry, spline field. Turn that off. Then create new data. This will be the button. There we go. So there's a setup. That's nicely done. I'm going to be recording over 800 frames, so I'm going to set that in now whilst I remember. And set the timeline to be the same because I want to get lots of data. Now I've got the keyframe here for the driver, which I'm going to set to frame 800. So if I scrub through and we reach the end, I'm not quite at the end. Let's just go to the default view. Try and get this as close to the end as possible. Not 100%, because otherwise the front ends up down there and then the carriage starts crapping itself. So I'm going to say 8.8. I knew that beforehand, so no, it wasn't a wild guess. So yeah, I want the wheel cage, front wheel cage, to be as close as possible towards the end of the spline. Now, if you're using a looped spline, then you could go to 100%. But in this case, this is good enough for me. I'm not going to see this go any further than this position, so I don't need any data beyond here. Okay, so we've got that nicely set up. And in regards to recording the data, I'm going to just be... Oh, I wanted to start from frame 0. What am I doing? Driver. Get that keyframe. 0. There we go. Now, I'm just going to do a nice linear animation, I think. Or even this, actually. This will be fine. But what you need to consider is that on the tight curves, that's where you're going to want as much data as possible. So as you can see here, it's stepping a little bit. So you could, if you wanted to gather as much precision as possible, what you'd want to do is maybe put a keyframe in here, get some easing going, or maybe a couple of keyframes actually on either side. And then just kind of have it go slower on those tight corners, just so you get as much detail as possible whenever you're navigating those parts, because all this is going to be doing is gathering data, so it doesn't matter if the animation looks really weird. It's just as long as you're getting a smooth motion across the tight curves. On the straights, it doesn't matter because you're probably not going to be adjusting the front wheel cage, but again, just something to bear in mind. If you want that extra precision, do that, but in my case, I'm going to be lazy, not too fussy, and just do a nice linear motion all the way through and gather data based on that. Okay, so we've got the carriage keyframe. Now what we need to do is get the front wheel cage to be offset again. So let's get the locators back, and of course I deleted it. I'm going to say target. You should be familiar with what I'm doing here. So 8.15. There we go. Set this to locator, material, freeze 100%. So there we got what we had before. Now what I'm going to do is go through, and in the data gatherer we have the front wheel cage manual offset, which offsets this. I'm going to go through and keyframe where we need to do those offsets throughout this whole spline. Now what I did in the final result, which is not shown in this video, what I did was I went into complete precise detail, but for this I won't go as precise, and I don't think you really need to for most cases. So if I go in the target and I create a camera and I set that camera to top view, there we go. Then I'm just going to zoom in nice and tight, and let's just check nothing's wonky. Yeah, there we go. This one, that's from the aim constraints, that's fine. Okay, what we're going to do is turn off the geometry, get rid of the background assets, and this is typically how I would start keyframing, just so I've got a nice position, and I'm going to zoom in as tight as possible. Now when I scrub through, here we are on that first easy bend, you can see there's an offset here, so it's up to you if you want to do the adjustment here, but it would be very minute. So if I went to 0.0001, even that's too much. I mean, this is an incredibly tight value here, so if you want to go to the length of that in order to do the keyframing, so be it. Should have set that's 0. So it depends how much precision you want. You know, you can start doing the keyframing based on those small offsets or not, but in my case I'm probably going to go from something like this, in which case I wouldn't even bother keyframing that part, just because it wouldn't be noticeable. What I'm going to be doing is keyframing parts like this. So anyway, without further ado, I'm going to start keyframing throughout the spline where I feel necessary, and then come back to you with the results. Okay, so I've keyframed the front offset of this wheel cage, and as you can see, everything's nicely done. Got the locators nicely locked in place. Now in terms of the keyframes, I've just keyframed a tight bend there and a tight bend there, and then a few bits where we go up that ramp there. But apart from that, everything else is pretty much the same. So what we're going to do is take the data that we've gathered there, and then plot it into, if I expand this a little bit more. Oh, come on, Cinema. There we go. So we're going to plot the data, or the keyframes that we've got, into this graph. Now, obviously at the moment, nothing's plugged in, so this record button doesn't do anything, and these frames don't do anything, this doesn't do anything. So we're going to start creating the Python tag. That's also why I've got this documentation open on the left. So if we go on the new front, it's important we use this, especially if you're going to be copying and pasting the code, because everything's going to be relative to that null. You can code it differently if you want to place a tag on, say, the data gatherer instead, but the way I built it was built in relation to where this is. Don't know if it's important or not, because I've not tried placing tag anywhere else. So anyway, what you get with the default tag is something similar to what we'll be needing. So I'm just going to try and break down what we see here, and then explain why we're not going to be using it. So what we have here is define main, which is what you expect with most scripts. And this is just going to be called, as you can see here, when the tag is executed, it can be called multiple times per frame, similar to tag data.execute. So this is common with most code. Basically, whenever you hit execute, whenever it's meant to be working, this code will run. So what we'll have in here is basically something to say, when this button is pressed, send a signal, essentially. And then this message function here will process that signal and then execute the code that we want to be executed whenever that button is pressed. However, I'm not going to use this just because I still don't fully understand how this works. I still can't get it to work. So what I'm going to be using is a sample of script which I managed to get a few years ago. And I wish I could credit who did it, because it's been like a life changer for me, but I can't remember. So yeah, this script is basically just going to be replicating this. It's just to get the button to work, and the script is, there's plenty of different ways of getting user data buttons to work. You can find them all over YouTube and various blogs. I found mine through a blog. So yeah, I'm just going to use what I know that works and go from there. I'm just going to pretty much just copy and paste what I had before, and then just kind of reverse engineer it so I can explain what's going on. So I'm going to delete that tag which we just created and replace it with the one which I made earlier. Now we can get rid of half of this because we've got functions for 2 buttons and we only have 1 at the moment, so we'll just delete all that. Okay, so I'm going to start with explaining how to get the button to work, because that's the first part of the puzzle. We need this record button to do something. I shouldn't have pressed that because I could have accidentally executed things. Okay, anyway, it goes to show that it's not working properly yet, so that's somewhat of a not really a good sign, but I know why it's not working. Okay, so here we've got data gatherer equals op.getObject.getUp. So what that's going to do is, as you can see up here, they've nicely included this in the script now. op equal, well, it's basically, as you can see here, the Python scripting tag. So op, which is the Python scripting tag, which is this, dot get object, which is the object the scripting tag is attached to, and then we say get up, which will be the object's parent, in our case data gatherer. So that's why I've named this variable data gatherer, because it's basically just getting that location relative to this tag, which we'll be needing for this script. Then here we've got bc equals C4D.baseContainer. That's just to shorten this, so I don't have to keep writing it. And then this bit is where things start getting a bit murky for me. What I've got is data gatherer, which will be this object, and then add event notification. And I'm not entirely sure how the nitty-gritty details of this work, but basically the way I interpret it is that we're sending a signal from the data gatherer, and in our case it will be coming from this record button. And then this message function here, this will basically process that signal, and then say at the start of this function, if that signal is coming from the user data ID of 6, which would be this button, but in our case it's not because it's not working. In our case it would be 8. So if we set this to 8, say if this button, this record button, is pressed, execute this function. So I'm just going to demonstrate that it works now because I've just updated, or at least the button works now because I've updated the ID for it. So if I say print, it works. And then we'll get the console open, which I have here. I'm going to clear that out because there's going to be lots of error messages. So what we have so far is we send a signal with all this, or we get location to say where we're sending the signal from, and then we process the signal with this. Then we say if it's actually coming from this button, then print it works. So if I get the console up and I hit record, there you go, it works. However, if I set this to something which wasn't like what we had before, which was 6, if I press it, nothing works. So it's matching to that ID specifically, which is great. So that's how we get the button to work. I don't want to take too much credit for that because I didn't come up with that code. If you know how this works specifically, like all the details of it, please let me know in the comments below, because it pains me to just copy and paste code which I don't fully understand. I know it works and everything, but it's, yeah, I'd like to know what I'm actually doing, you know. Anyway, I'd be grateful if you do know the answer. But in the meantime, I'll just continue. Right, so the actual function of that button, this is going to execute this code whenever the button's pressed. And we start with spline equals cinema4d dot spline data. Now this is basically saying we're going to get a variable called spline and we want it to be equal to cinema4d dot spline data, which will prepare a spline. It won't create a spline object in the scene or anything, it's just in the background it's saying, okay, we're going to be working with a spline, which we will be using to plot this graph later on. So we're just going to be fabricating a spline in the ether, essentially, at the moment. Then we have data gatherer equals op.getObjects.getUp, which we written down here earlier on. It's just that this seems to be out of the scope of this function, so whenever we try and call it in here, it can't seem to find it. So I've just written it again so it can be found again. Then we have frames, which will be relating to this parameter we got here. Frames equals data gatherer, which is in this object, and then ID user data 7. So let's see what the ID is, 6. So that should be 6. Then after that we have frame counter, which equals 0, and I've written do not change. Now, as I've written after that as well, it will be used to track the current position on the timeline, because the rest of this function will be iterating through each of the frames on the timeline, and that frame counter will it will essentially let the iterator know which frame it's currently on. Because without it, you'll go in the first iteration, and I'll explain in more detail after. In the first iteration, it'll go, okay, we'll gather all the data and stuff, plot it in the graph, then move to the next frame. Then in the next iteration, it will just revert back to 0, do the same thing, move on to the next frame. So you just end up with 0 and 1 value, or 0 values, sorry, all the values placed onto frame 0, which is not what we want. We want it placed along the whole timeline, or from the whole timeline. We don't want all the data within this small corner here. So again, I'll try and explain that better when we actually get to that part of the code. Okay, so we've got in the for loop, say for each iteration within the range of frames plus 1. So we've got 800 plus 1. So within 801 frames, and the plus 1 is just for a little quirk, just to make sure we get the last bit of data. I don't know if it's still needed or not, but it was when I first started building this. And there's no harm in having extra data. So we begin with this variable x underscore back, which will be relating to, just squeeze this down a bit for a moment, scroll down, so we've got x back, which will be relating to this value here. So we say op.getObject, so we go to the scripting tag, get the object it's attached to. Then we say getPred, which will be the predecessor, and then we say getPred again, which will be the predecessor of that. Then we say getTag align to spline, which will be this, and then we say cinema4d.align to spline tag underscore position, which will be this value. So we're getting this value relative to where the scripting tag is at the moment. So this x underscore back will be equal to 0%. And now for the y front, that will be for the front position, which will be plotted in the y-axis. That's why I've named them x back, y front, because x back is basically going to be on the x position, we'll be plotting the back wheel cage, and then y front will be going on the y position and plotting the front wheel cage. So for y front, we say op.getObject, which is the tag, get the object. Then we say getTag, which is aligned to spline, which is that. And then we say get the position again, which will be 1.0534. Then we have a print command, which doesn't have any function other than it puts things in the console so we can see what's going on. Then we have spline, which is that thing we were fabricating earlier on. We're saying spline.insert not x back, y front. So we're getting x position and y position of the knot based on these position values which we stored up here. So we're saying spline.insert not 0% for the back position on the x-axis, and then 1.0534% from the front wheel cage on the y-axis of this. Now, this insert knot is needed before we can actually set the knots. That's just how the code works, it seems. I tried to do this without this part, and when I tried to set the knots, it did 2 of the knots and then said we've run out of knots to plot in the graph. So you need to kind of gather or collect enough knots before you can actually plot them in here. So we're basically saying, okay, when we're inserting knots, we're getting about 800 or however many, 801 knots, which we can then use to plot in this graph. Okay, so that's where we get into this part. So we say spline.setKnot, and we begin with the index. Now this I represents this iteration here in the for loop. But what this iteration is going, the value of that iteration will be used to define the index of that knot. So think of it as, say we've got some knots here. This would be index 0, this would be index 1, this would be 2, and this would be 3, because that's the order they're in. You know, if we rearrange them, you know, it's, oh, I was actually surprised that would have worked then for some reason. But yeah, basically the index will say the order of the knots that will be creating the spline. So we want that to match the iteration. So on frame 0, the first knot will be 0. Frame 1, the next knot will be 1, and so on and so forth. Then we have cinema4d.vector. This is to do with the position of the knot that we're going to be placing on here. So here we've got cinema4d vector x back, y front, and 0. Now these correspond to x, y, and z values. Now because we're plotting on a two-dimensional graph, we don't need, say, z values. We just need the x and y, which we've set as x being x back, which was 0%, and then y front, which on the y-axis was 1 point something or other, so it'd be something like that. That'll be what the first knot would look like, and then as we plot them, they'll increase along the graph. Then we have 0, which relates to flags, which I'll just go and explain here actually. So we're on set knot. Actually, yeah, in order to find this, all you do, cinema4d Python documentation, then the first one that pops up pretty much. And then in here, you can type in what you need. I'm just gonna scrub this across a bit, because we're not really seeing the viewport anymore, we're just looking at this tag. Okay, so just focusing on this, say set knot, working with spline data. So as you can see here, we've got spline data dot whatever, and you've got lots of different parameters relating to creating splines. But what we need is this set knot. That's what we're going to be doing here. This is where you find the information for all these things. So as mentioned before, so in regards to the parameters, where it says the order of them up here, in the parameters we've got index, the knot index, which was that I, and then we had the knot position, which was that vector. Then we had 0, which are the flag settings, and it says here what those flag settings do. So if I wanted to break the knot tangents, I could write in flag underscore knot underscore t underscore break and things like that, but I don't need any of those, so I've just set 0. Then the next one, where we've written false, that's something which I don't know what it does, but it just says do not change this. So I've just set it as false because that's what they've set in the default settings, and it says don't change it, so there we go. I'm just shrugging my shoulders at that one. Then after that we have two cinema4d.vectors, and they relate to tangent left and tangent right, which is basically the tangent handles of the knot. So if I create a few of these, you've got the left tangent handle here, and then you've got the right tangent handle here. and I'm saying just set it inside the knot because I don't need those tangent handles at all. I don't want them, to be honest, but I'll just set them as 0 for now and it seems to do the job. And then at the end we've got this bit here which I've just copied from here. So we're basically saying the spline knot interpolation, and I've set mine to cubic interpolation, so I just copied that last bit here and then placed that in here. Okay, so we're setting the knots and we're going to be doing that for each iteration in this. Now we get to this part where, as I've left a nice little comment here, we move along the timeline by 1 frame and then set it as the current frame. That's because if you don't do this, it will the script will iterate through all the frames without actually, well, in the for loop it'll go to the next frame and then it'll just forget where it was and just start again from frame 0, because it'll just treat it as each iteration as a new script to execute pretty much. So it won't care about what it did before, it'll just repeat the same thing over and over. But what we need is to make sure that it actually, when it hits next frame, it actually goes along the timeline based on its previous position. So what we have is document FPS, which equals cinema4d.baseTime, and then we've got float, which you can ignore float pretty much, just make sure these integers are not integers. Getting the float values and then matching it to the document FPS. So that will be this. That's important because if you change this FPS, you want to make sure that when it goes to the next frame, it actually does go to the next frame and not some sort of weird increment between different frames. So if I set this to 25 instead of the document FPS and then change this to say 30 FPS, it won't work properly. Basically it will just go to almost 1 frame in 30 FPS because it'll just be going, yeah, I don't want to explain it further. I'm getting confused already, but basically just set document FPS in there. That's what this is doing. Just getting document FPS and making sure that it doesn't break whenever we change this value. Then we have next frame equals cinema4d.baseTime. Then we've got float and we say frame counter plus 1. So the frame counter, as mentioned earlier up here, that will be keeping track of where we are. So on the first iteration we're on 0, so we're on frame 0. And we're now saying get frame counter, which is frame 0, and then add 1 to it, so we move up a frame. And now we say the new current frame is equal to document FPS multiplied by the frame time. That's how to convert the FPS into an actual frame on the timeline. And then we say doc.setTime equals, or it's, sorry, doc.setTime is the new current frame which we've set. So basically saying we get frame 0 and match it to, like, relative to the document's FPS, we say frame 0, go up a frame and say this is now the current frame, frame 1. Then after that we call this doc.execute passes, which I'll just type in here. Ooh. Execute passes. What this does is it'll animate the current frame of the document. This is very important. And then it also says to update the editor, you then need to send an update message using cinema4d.eventAdd. So that's why I've got this cinema4d.eventAdd. It's just to make sure that things update. So when we go to the next frame, what this will do is make sure that it's factoring in the animations going on here, so it knows that this carriage is moving. Otherwise it'll just keep repeating the same values from frame 0 because it won't acknowledge that these align to spline tags have even updated or moved or anything. It just won't recognize. So in here we say for the first one something to do with threading, which I just dismissed because it wasn't relevant to me. Then let's move this over a bit again. We have true for the animation, so we say are the animations going to be evaluated? Yes, we want them to be evaluated. Do we want the expressions to be evaluated? Yes, we do want the expressions to be evaluated. And then on the last one says caches are evaluated. doesn't really matter in our scenario, but in case they are needed, yes, we want those to be evaluated. And then we have the build flags underscore internal renderer, which will be this one here. We're saying rendering in the editor because we're going to be looking at what's updating in the viewport and whatnot. So then again, C4D.eventAdd because we have to. And then we have frame counter equals frame counter plus 1. Now that is basically to match the new current frame here. The thing is, this value is of base time. Well, it's a base time object, not a numeric value. So it's hard to increment that because there isn't a numeric value. So I'm basically substituting that with the frame counter. So saying frame counter equals where we are at the moment plus 1. So it matches this here before we end up doing the next iteration. So that's the main bulk of it, really. And then after you've finished iterating through all of that, so just to go over again, we're getting the back wheel cage position, the front wheel cage position, creating a knot for those values, and then we're inserting it into this graph, which would be somewhere like down here for the first one, and then we're going on the document FPS. Sorry, I just set that back to 0. So we're going to go get the document FPS, which is 25 frames per second, calculate, get the frame counter, which is 0, and then add 1, so we move to the next frame, calculate the current frame in the timeline based on the document FPS, and then we're setting that as 1, so we're now saying we are on frame 1. Then we're updating all the animations in the scene for the next, in preparation for the next increment, and then we're setting the frame counter to be equal to its current value plus 1, so it matches what we've got down here, which is frame 1, and then we've just got a print value here which will go in the console, and then we repeat. So we go through each of these one by one, storing the data of these X and Y positions into this graph and slowly plotting them as we move along. So that's what the for loop is for. And then at the very end, we've got these delete not bits of script, and I'll explain what those do in a second actually. So, and lastly we have data gatherer equals spline. So this is going to be, this user data will be in reference to the spline field here, so we want to make sure that that's right, which it's not, it should be 7. So change this to 7, and this will be equal to that spline we've been building this whole time. It'll just take the spline we've been building in the background and then placing it into this field here. Okay, so I'm going to comment out these two bits here just for now. I'm going to do frame 0. I'll go to the very start, and then I'm just going to maximize this. We don't need the other thing now. Okay, so we've commented those out. I'm just going to minimize it for a moment just so I can see what's going on. Frame 0, we've got the data and we want to record. So when we hit record, something's happened. We got the point that we needed, except we also have these two which have appeared out of nowhere. So now that is why we have these spline.delete not, because it will delete those two knots which are just added for no good reason. So delete those, go back to frame 0, hit record, there we go, we've got the knot that we needed. And if I were to go in a separate window and I select this knot, you can see we've got on the X point 0, and then on the Y point it should match that 0.0105, and then again you're going to have to divide this value by 100 to get the real number and not the percentage, in which you've got that. So beyond this 5 you'd have 3, 9, and then whatever other integers are hidden within this value field here. So it's worked, we got the data that we needed. So if we go back to frame 0, we can delete that there, and we're going to say 800 frames, which is what we want. Everything's working now, so we don't need that anymore. and as soon as we hit 800, you'll see the train will go all the way along, do its full animation, and it will be up there once it's finished. So let's give that a go, hit record, and it will take a few seconds, shouldn't take too long. There we go, we got the data. That's the data recorded. We've got the back position recorded in the X part of the axis, and then in the Y part of the axis we've got all the front wheel cage values, which then means we can save this data. I'm going to call it main spline V1 wheel cage separation, and then say 16.3 centimeters, just so we know this is the spline that we used. In case we have to change the spline, you'd need a new set of data, unless it's the identical spline that we're using, then it wouldn't matter. But I've got the spline here so we know which one it's relating to. Wheel cage separation, because that's what we're going to be using this data for, and then we say the value of that separation, which we put is as 16.3 centimeters. And you can save this either in a different database, but I'm just going to keep it locally to this scene because I don't really need it anywhere else. And then again, you can place it in presets and stuff if you want to go into that. Anyway, I've saved that. Now, if we get the train and carriages, we get the train here, what we're going to do is, inside this espresso tag, we're going to start setting things up. And then shortly after, I'm going to create a carriage just to show you how quick and easy it is now that we've got this data. So we begin with the driver, and then we get that to drive the back position. Should be 0. We've not done anything for the front, so that's why that's still there. Then we get the range mapper, position of this, plug it into the input. We keep everything the same, except we're going to load that data we just created, so that's now fed into here, and then we feed that into the new front. There we go, it's back in position. Already this is a promising sign, because all we have are these 4 nodes, and it already knows where it should be. So if we scrub through, oh, we've not set anything for the driver, that's why. So set that to frame 0, and then say at frame 800, I'm going to say 50%, just so it's something different, so it's not identical to what we had when we recorded the data. So then here we are, it's looking promising. Let's just double check, get the locator, and then get the one in the back, which no doubt I've deleted because I just have a habit of doing that. Okay, so let's say target, you know the drill by now. Set the colour, we need to set the position in a moment. Oh. Whoa! A bit haphazard there. And place it in the carriage. I want to make sure it's 8.15, and get rid of the y-axis and the rotation. And there we go. You can see it's nicely locked in place. We've got that data and it's fed into this new train that we've built. Now, this is where it becomes really handy. Create a new one, call it carriage. What we do is, in here, I'm just going to clear that out because we don't need all that stuff. We're going to get the new front of this train, and then we're going to get a range mapper for that. That's going to be important. And then we're going to get another one for after. We're going to get the back position, and then we get the front position. So I'll just show you without first, and it's going to be wrong, but we'll get there. We'll plug this into range mapper, then load the preset, load that spline, and plug it in. There we go. Now the front's relative to the back position. That's why it's freaking out as I was doing that. As you can see here, I've got the front of this carriage to set the back of the next carriage identically. What we're going to do is plug this into a range mapper, and for now I'll just use the data that we've already gathered, and this will set a 16.3 centimeter offset between those carriages. And if I scrub through, you can see the yellow and green locators are nicely locked in place, and the same for this one. So the data is working. However, I don't want 16.3 centimeters between the carriages. I want something tighter. In fact, I want 8 centimeters. So what we're going to do is pretty much what we did before. So I'm going to hide that. I'm going to go to the data gatherer, scrub all the way back to the start, and go in the carriage data and change the wheel cage separation to 8. So we've got 8 centimeters. Now we're going to need to gather data for this new measurement. So I'm going to get the target for this. I'm going to set that to, and say 0.15, because that's where the back position is. And then I'm going to say add 8 centimeters. There we go. So we're in position. And let's make sure there's no keyframes there. That's good. Cool. Oh, actually, no, there are keyframes there. What am I about? Delete those. Okay, great. Oh, something's wobbled again. This is something you may need to be aware of. Wary of. I think it's as soon as it hits that helix, so you may want something to clamp that value. Yeah. So we got that. So this is prepared for gathering more data. Now there is one more thing you need to be aware of, which is at the end, in case you're using a smaller carriage, that smaller carriage may need to reach a little bit further. So say, where's the driver? There we go. Get that last keyframe, and then maybe say 99. Nope, 99.4. Ooh, there we go. Okay, so I'm going to go up to there instead of from the position we had before, just so we can get as much data as possible. Probably won't need any at that point, as I didn't bother recording there last time, but again, just for practice, that's what you want to be doing. Okay, so same as before, I'm just going to go through and keyframe each of these new positions, and then yeah, I'll come back to you once I've done that. Okay, so I've gone ahead and recorded the new front wheel cage offset of 8 centimeters. So if I just scrub through, you can see this nice tight bend. You can see the locators are nicely in place. So what we need to do now is, same as before, we're just going to record the data. However, this time, I mean, I could record it in here and then just save a new preset. That would be fine. However, I do want to show you how to create a new set in case it's ever, in case you ever need to do that. So I'm going to create a separator. Just going to create a separator line, doesn't need a name. The separator doesn't serve any function other than to make things look a little bit tidier. So you don't need to put that in there. So carriage gap 8 centimeters. So yeah, that's the separator there. It just separates the two sets of data we got. So I want to put 800 frames in there and then link all this into the Python tag we have. So it's very simple. Just take the previous button we had, copy it, move down a little bit, and then paste it. Call it button 2, and then update the IDs to match the ones we've just created. So in here, the record button is 12, so we can set this to 12, and then what do we need next? The frames, which would be ID of 10. So we go in here, set those to 10, and then the last part, which is at the very bottom, is the spline field, which we set to 11. Oh, there we go. Okay, so that's the second button done. Same as before, it's just linked to these parameters here. So starting from frame 0 over 800 frames, hit record, we should get the 8 centimeter gap data prepared for the train and carriages. So that seems to have done. So I'm just scrub back, just check that it's all there. Yep, all good. Get rid of that. Bring these back. And now, go into the carriage, in which its back wheel cage is being offset from the front of the train. And take the range mapper there Oh, we need to save the data first, don't we? So we save the 8cm data, so we say main spline v1, carriage gap 8cm. Great. So now when we go in this range mapper, we load in the 8cm one. And there you go, we've got 8cm gap between them. Now, oh, what's going on there? I think there's something going on with this aim tag. So you may want to disable the banking in that tag in the constraints. You may want to turn that off. Or you may want to use protection tag in case that helps, but either way, yeah, it's not been detrimental for my rig, but just in case it affects yours, that's something to bear in mind. Okay, so we scrub through and everything is nicely locked in place. Now there's a few other bits to finish off with, and the first one is to do with the link, which is going to be placed between the carriages. Very sweet and simple. And then after that I'll show you how to deal with looped tracks, so stick around if you want to hear about that. Okay, so I'm going to set the cube to about 1 centimeter, and then constraints. I'm going to do 2 transform constraints and then 2 aim constraints, but we'll start with the transforms first. So we need the front of the train, which is there, and the back of the carriage, which is there. There we go. So we've got it positioned between the 2 wheel cages. That's good. We're going to move this cube up a little bit, and then, you know what, I'm going to hide these carriages because I can't really see what's going on. So I'll hide that one, and then hide that one. Okay. So we got the cube. Now what we want to do is create the aim constraints. So go back into here. Nope, not up. Aim. Clicking the aim tab. And once one of the axes saying plus Z plus, and then the other one saying Z minus. So we want the, clear these up a bit, we want the front in one of them and the back of the carriage in the other. There we go. Now in the cube we want that's to be 8 centimeters because it should be 8 centimeters, and then these I'm going to say 0.1, no, say 0.4, maybe 6, okay, and then this one can be 0.1, okay, cool. Then in the middle of the cube I'm just going to put a little sphere, say 0.3, that works, okay. And just for demonstration I'm going to put a locator on that, and as you can see, nicely locked onto the ends, and as we scrub through you'll see they are locked between those 2 points. If I go to top view, in fact that might be easier. Then maybe make this locator green as well. Custom, say some sort of green, that shall do. Okay, as we scrub through, there's a bit of a delay, but it is staying nicely constrained, so that's a good thing. I'll figure out what that delay is in a moment. Oh, it's because it's not in the hierarchy. Okay, if I place it in the hierarchy, which would be a wise idea, scrub through, there we are, much better. Okay, so everything is working as intended. Caught me off guard, that. Okay, so as you can see, perfect. Nice 8 centimeter offset throughout the scene. So if I go back to perspective. Okay, great. So that's that. Now the last part, which is to do with looped splines. So if I go back, I mean, if you're happy at this stage, that was everything. So yeah, feel free to use this, but I'll just shift onto this. Okay, so this is what I use for my final animation. I've got a small train, which is basically one wheel cage, and then some really long carriages just to demonstrate how well this can deal with very wonky splines. So I've got this loop. Now, as you can see, if I go in the back carriage, I've got the driver going from 100% to 0%. So this back wheel cage here, the position of it will go down as we move along the track. Okay, and then usually when the position of an aligned to spline tag hits 0, it will just stick there because it can't go to negative values, it can't go below 0, nor can it go over 100%. But as you can see, if I scrub through here, watch carefully, we're almost at 0, but then we wrap round back from 100. So how do I get it to do that? How did I get it to loop along the spline? Very simple really, because if I just went like this, this is what we had before. Now what we have, these two range mappers added, and they literally just have this modulo text box enabled. So you've got input range as %, output range as %, but the values in those are the defaults. I turned off use spline just for the sake of it. I don't know if that was actually essential or not, but I just, it didn't impact it as far as I'm aware. But the main thing is modulo. So what this is doing is, if I get two result nodes, I plug this into here, this into here. You can see everything's fine at the moment. We're at 0.998, which is relating to this. I mean, it's 99.77 whatever, but that 8 is basically rounding up this value here. So now if I go back a frame, or maybe back a couple so we can get some more decimal places, you can see here 0.003 is rounded up this value to 0.3%, because bear in mind percentage will be 1/100th of a real whole number. So this is what's being displayed in this result here after the modulo. However, if I didn't use modulo, as you can see here, 1.003, what you would have is 100 point, well, what's rounded up to 3, but here it would be 100.27 whatever, and obviously the aligned to spline tag can't go over 100, so it would have just stopped at 100 and wouldn't have moved. So that's why I've used this modulo. It's basically wrapping the values between 100%, 0% and 100% and constraining them within that. So with every time it's 100%, it'll just drag it back down to 0% and continue from there. And the same with if you hit 0%, if you drop to 0%, you keep dropping, it will send that overflow back from the top, which would be 100%. So that's why I've used these modulos. It allows me to loop along the loop of the track as many times as I want. I also used the modulo for the wheels as well, just so it didn't rotate to ridiculous values. It's just its rotations were constrained within 0 and 360 degrees. Not essential, it was just to make things a bit tidier. Anyway, I'm going to do a quick follow-up video so I can go over some, I'll say, warnings, I guess, with this rig, just so you don't jump into it and put full faith into being the solution to whatever projects you're working on. It's not really to do with functionality, because as I've shown, it works really well. Like I'm to be honest, quite proud of myself. It does the job really well. However, in the follow-up video, I'll be talking more about efficiency, so you know when to use it and when it's appropriate to use it, and also to prevent any issues that you may encounter, because I fumbled a couple of times. I didn't understand why things weren't working, and it turned out they were obvious once I'd realised what the mistakes were. But obviously if I've made them, then chances are you may make them as well. So I'm going to do a follow-up video in regards to that. But other than that, if you're happy with what you've seen so far, let me know. If it's a bit too complex, fully understand that. I mean, I think I may have alienated the majority of people by this point, but if you made it this far, very well done. I think in the next videos I'll be doing something a lot more beginner friendly, because I've had some requests in regards to that. But I do also have a lot of techie nerdy things lurking in the background, which I'll be well, I want to share at some point, but it may not be in the immediate future. Anyway, let me know what you thought of the series, and I know this has been an incredibly long one, so I'll try and cut it short. Yeah, let me know your thoughts, how this went. Have a great day, and hopefully I'll see you in the next one.